Hello and welcome to Richardson RFPD Test Chat. This is Peter Dietrich. I'm Senior Engineer for Energy and Power at Richardson RFPD. Today I'm here talking with San Juan. He is Power Technology Specialist from Wolfspeed.
Hi, Peter.
Hi. Thank you for joining us today, San. A question we often must answer from our customers is how silicon carbide MOSFETs differ from silicon MOSFETs or IGBT and GaN transistors. Can you offer guidance on this topic from your perspective?
Sure, that's an excellent question. I like to refer to this chart for this question because it visualizes how these three technologies plays out really nicely. As you can see, silicon carbide, it really dominates at the high performance, high power, high voltage applications. The reason is silicon carbide as a material is excellent in blocking high voltage, and it has fast switching speed, not as fast as GaN, but very good at medium and high frequencies. And also it has excellent heat dissipation capacity, and the RDS(on) can stay very flat over the temperature. So that means it can handle very high current even at high temperature. So when it gets to high power, high voltage applications, silicon carbide is the absolute best choice because MOSFETs, silicon MOSFETs cannot handle as much current, and silicon IGBT cannot switch as nearly as fast. So over the year, we also see silicon carbide has continuously improved on cost and getting down to lower voltage applications. So actually in this year, 2020, Wolfspeed introduced its 650 volt silicon carbide MOSFETs. And we are seeing with the new product, we are going to several regions that need 650 volt, but high performance. And we continue to expand into lower voltage and medium cost applications. And then we go down to silicon. As you can see, silicon is broad. It covers everything from 5 volt to 900 volt. That's the MOSFET. And then the IGBT can do 650 volt and medium voltage. However, it's been around for decades. The good things about things being around for so long is the cost is fully optimized. However, it's also been exhausted, the performance. So it cannot be improved to further better performance. It's just good enough for low-cost applications. Finally, let's get to GaN. GaN is the new kid on the block. People talk about it and say how fast it is. However, it's still not a very mature technology. If you look around, most companies are still struggle to make reliable 650 volt devices. You seldom see anything beyond 650 volt. And it's actually more mature on 200 volt and below applications. Of course, GaN does switch the fastest because it's a lateral device. So it's comfortably sitting at a very high density, high performance applications, such as some of the 650 volt, 65 volt, and 100 volt chargers you're seeing in the market. However, because it's a lateral device, it also has problem to handle high current and high power. So far what we are seeing is it's limited to lower voltage and lower power applications.
Well, noting the voltage level in your response that serves as a determination for the preferred technology, can you highlight a few of the typical applications where silicon MOSFET have gained broad adaptation?
I think you mean silicon carbide MOSFETs.
Of course.
Yeah, so yes, here is some of the applications that we're seeing adoptions. You can see here we separate them into energy, automotive, light industrial, and heavy industrial applications. One sector I want to highlight is the automotive sector. As you know, Tesla has made the silicon carbide sexy in electrical vehicles because they put the silicon carbide into Model 3 drivetrain. However, even before Tesla, we are shipping into high volume into onboard charging, onboard DC-DC, and off-board charging. The reason is very simple. EV is power hungry. we're talking about a drive chain which is 150 kilowatt to 250 kilowatt. We're talking about off-board charging starting from 50 kilowatt going up to 350 kilowatt, and people are talking about megawatts, so they can charge up the car in 5 minutes, 15 minutes. And then on-board charging starting from 3.3 or 6.6 kilowatt, and now customers are asking for 11 kilowatt and 22 kilowatt. So all these high power applications, they are potentially running at high temperature environments, and they need to be all fit into the EV or the charging station. So as I mentioned, right, silicon carbide is good for high voltage, high power, high temperature, and high power density. So automotive is becoming the excellent application for EV, and we are seeing it's definitely driving the volume these days. And then for energy and heavy industrial, we are also seeing a lot of adoption for silicon carbide already. The reason is the same. They are running at high voltage and high power, and either they need to improve the efficiency or they need to reduce the weight and the size of the product, or both. Finally, light industrial, we've been shipping in high volume for a long time with our silicon carbide diodes. But now with 650 volt devices and industry moving to even higher efficiency requirements such as titanium plus, we are seeing more and more adoptions for silicon carbide MOSFET as well.
Nice. In closing, San, please provide a brief overview of Wolfspeed growing silicon carbide portfolio.
Sure. Wolfspeed is a vertically integrated company. So right now for our diode and MOSFET, we are producing up to 1700 volt rating diodes and MOSFETs, and up to 100 amp current rating, which is limited by the package. So when you put our dies in the power modules, we can offer the same up to 1700 volt rating, but we can now offer up to 760 amp current rating. That will be a half bridge module that we produce. One question that people continues to ask is, can you parallel silicon carbide dies or MOSFETs easily? So here we are. We are paralleling 12 pieces of dies inside the module, and they're working beautifully. And finally, we also offer bare die products. Unlike some of the other companies, they don't offer their latest technology as in die form. Wolfspeed does offer our latest technology in die form, and we are working with many module makers such as Danfoss, Winkotech, and Star Power. So if you are working with any of the module makers, or if you want to make any customer want to make module by themselves, we do offer our dies up to 1700 volt rating and up to 190 amp, 96 amp current ratings.
Thank you, San. Clearly, Wolfspeed is determined to maintain a leadership position in the growing adaptation of silicon carbide technology. We appreciate your time today, and then thank you all for watching our test chat video. You can learn more about this and other topics on Richardson RFPD GaN and SiC Tech Hub. Please follow our Ask an Expert link to submit questions related to design challenge you may have.
Thank you, Peter. Nice talking to you, and look forward to talk to you again.
Thank you, San.